Our project is about collecting OU excellence in different kinds of sustainable technology development. So many people at the OU are working on really cool sustainable technologies, things that can really work towards a circular economy. And our project is basically trying to link those different technologies together. So the outputs from one technology feed as the inputs into another.
The Splice network as a whole is contributing to a sustainable world. The benefit of the Splice network is it's that a collective of scientists from different disciplines that may not traditionally work together are all looking at a problem. And so you tend to get a very coordinated response to the problem that's present, and we're seeing failures in that currently when we see waste. We have wind turbines that solve one problem, but now we're stuck with a load of 20-year-old wind turbines that we don't know what to do with. We have electric cars with old batteries that we don't know how to recycle. And so as scientists, we need to start looking at the problem as a whole and how we're going to look at it from beginning to end. And I think that's what the Splice network at the OU is doing. It's bringing together scientists to tackle single problems.
The best metric of our success is in the ideas that leave the OU labs and really enter real-world application. And we have partnerships with industry and with other collaborators from different universities worldwide.
So in terms of sustainability, we look to design molecules that you can put into the environment. It will destroy pollutants in that environment, but then we have to look at how we sequester back, so take out those things that we've put in.
So a lot of our findings can directly be used in real-world applications. And one example of that with the smoldering technology is we have a very strong partnership with the commercial providers of that technology. So ideas and findings that we have in the lab can have a really rapid pathway into application.
Recently, there's been a lot of development on how are we going to start to generate the same building blocks in sustainable processes from a feedstock that is not coming from a fossil fuel, that we can take it from something that we can continue to produce.
Some of the work that we've been doing on particularly the smoldering combustion technologies is in understanding the energy efficiency of those systems. And some of the work that we have at the OU has better understood or uncovered what the energy efficiency is and ways that we can improve the energy efficiency.
Myself and other scientists from other disciplines have been working with industrial partners who are experts in analytical detection of pollutants, and we're trying to build brand new national and international networks to be able to look at some of the most current pollutants that are being raised in our government and in our communities to see if we can be a centre for excellence to start to detect and develop ways to sequester these from the environment.
A lot of our work is really focused on technology development, and some of the techniques that we're working on really target some new emerging contaminants. So what we hope is that by demonstrating how some of these compounds can break down, some of these contaminants can break down in our systems, that will influence policymakers in deciding what levels of these contaminants are acceptable in the environment if we have ways to reduce them and to destroy them.
Has the thing that we've made achieved the goal that we set out? So for instance, if I'm looking at water remediation, have I been able to take dirty water and make it clean and usable for someone and then not introduce a new hazard into that process?
We do tackle some waste problems that are international, and a challenge that we faced is in understanding the nuances of those waste management challenges in places far away from us. And the way that we've attacked that problem is in forming partnerships with people in those places. So by having these real collaborations with academic collaborators and industry partners in international context, we're able to better understand those challenges so that the work that we do has a more direct impact.
For sustainability to be accessible and inclusive, we have to remember that not everyone has access to the same resource we do in the UK. And that when we're developing processes or ways to tackle problems in the environment or with waste, we have to consider that this needs to be low cost, easy to use. You don't need highly advanced technology to use it. And so as part of the Splice networks, that's one of the kind of key goals that we're aiming for is, can this be done at low cost? Can it be transferred to any environment regardless of what they have access to ensure that everybody can have access to things like clean water good ways to dispose of waste and sequester the harmful products produced.